Okay, now let's do the 10th one. So this is the function, so this will be now d by dx of this one. Okay, so this can be written as d by dx of a upon x raised to 4 minus d by dx of b upon x square plus d by dx of cos x. Okay, now you see this can be done using the u upon v. Okay, assuming this, no, this is in the quotient form, so we can use u upon v, but you see this is just a constant, so using this method will be a little bit lengthier. Okay, so you see this is simple constant, so let's take the denominator to the numerator. Okay, both in both this expressions. Okay, so now x raised to 4, when it comes to the numerator, it becomes d by dx, it becomes a into x raised to negative 4. Okay, minus, and this also same thing, when you take the x square to the numerator, it becomes x raised to negative 2. Okay, so d by dx of b, this comes out negative 2. Okay, plus, you know the derivative of cos x is negative x. Okay, that's it. Now see, this is, now let's bring a out. Okay, since this is a constant, we'll take it out. So d by dx of x raised to minus negative 4. Now this also, let's take b out, b d by dx of x raised to negative 2, and when you remove the brackets, plus into minus will be minus sine x. Okay, now you see this is in the form x raised to n, d by dx of x raised to n, which is equal to n x raised to n minus 1. Okay, the power rule. Okay, this is in the, so we can use the power rule here. Okay, so this is n, so it becomes a, this a as it is, 4 x raised to minus 4 minus 1. Okay, in this is the form, so minus b, so this will become minus 2 x raised to minus 2 minus 1 minus sine x. Now a into 4 will be minus 4a. Okay, minus 4a, x raised to minus 4 minus 1 will be minus 5. This will be negative into negative will be positive 2b x raised to minus 3. Okay, and minus sine x. Now you see this can be written as, now you see then x raised to negative 5 can be again brought back to the denominator. Okay, so it becomes minus 4a upon x raised to 5. Okay, so plus this will be 2b, this comes down, x raised to 3 x cube. Okay, minus sine x as it is. Okay, so this is the answer given. Okay, that's it. Now let's do the next one. Okay, okay, now let's do the 11th, that is derivative of 4 root x minus 2. Okay, so d by dx of this, so let's split it, d by dx of 4 root 2 minus d by dx of 2. Now you see this is root, sorry, this is not root x. Okay, root x. Now see, you see we can write root x as x raised to 1 by 2. Okay, okay, or this can be, and also be, can be written as in this form. Okay, root x can be written as x raised to 1 by 2, or vice versa. Okay, so let's change this to this form. So now taking this 4 out, 4 d by dx of, this will be x raised to 1 by 2. Okay, minus the derivative of a constant is 0. So now this is again in the form x raised to n. Okay, the power rule, so let's use the power rule method. So 4, and this will be, this is n, so n into 1 by 2 into x raised to 1 by 2 minus 1. Okay, so you see 2 goes 2 times, so this will become 2 x raised to, if you take the LCM of this, it will be minus 1 by 2. Okay, now again x raised to negative 1 by 2, let's bring it back to the denominator, so it will be 2 upon x raised to 1 by 2. Okay, now you see again this can be written back in this form, so we have 2 by root x. Okay, that's it. This is the answer. Now let's do the 12th one. What is 12th one? 12th one is, okay, ax plus b upon n. Okay, now d by dx of this one. Now you see this is in the form x raised to n. Okay, this is in the form x raised to n. Assuming, if you assume this to be x, this is x raised to n. Okay, so let's derivate this. Here we have to use the chain rule. Okay, because since we are assuming this to be x, we have to derivate this again. Okay, so that's chain rule. So let's first derivate this, assuming this to be x. Okay, so this will be n into x raised to, so this is x. Okay, so x is this one, ax plus b, n into ax plus b into raised to n minus 1. Now again, since this is assumption as x, we will derivate this again. Okay, d by dx, that is multiplied by its derivative of ax plus b. Okay, so this can be written as n into ax plus b n minus 1. So d by dx of ax plus d by dx of b, derivative of ax and derivative of b. So n into ax plus b n minus 1. So this is a, d by dx of x will be, derivative of x will be 1, plus derivative of b will be 0. So a into 1 is a. So okay, n into ax plus b n minus 1 and a. Okay, let's multiply this a here, so it become an, ax plus b n minus 1. Okay, that's it. This is the answer.